Hey everyone, I'm Eric James D. Oreta from BSIT2. So today, I'm going to explain and demonstrate my output in performance tasks in data structure and algorithm. So let's get started. So before we started, here is the problem. So the problem is the keys 12, 18, 13, 2, 3, 23, 5, and 15 are inserted into an initially empty hash table of length 10 using addressing with the hash function h of k is equals to k mod 10 and linear proving. So here are the basic steps on how we resolve the hash collision. So first is the open hashing where included the separate chaining. So when we talk about separate chaining is defined as a method which linked lists of values are built in association with each location within the hash table. So when the collision occurs, so simple to say that separate chaining ay gagawa lang tayo ng another box sa gilid when the collision occurs. So after this, I'm going to demonstrate kung paano ang separate chaining. Second step is the close hashing or the open addressing where included the linear, quadratic, and double probing. So mamaya din i-demonstrate ko yung linear, quadratic, and double probing. So here we go. Separate chaining. As we can see, I have already have an answer from what is the problem that we need to do. So the formula is in the top, which is the h of x is equals to x mod 10. So h means hash, then x is the key element, and the 10 is the size of our hash table. So first, the key 12. So 12 mod 10 is equals to 2. Next is the key 18 mod 10 is equals to 8. Next is the key 13 mod 10 is equals to 3. Next is the key 2 mod 10 is equals to 2. So why I'm replacing 2 in the index size of 2? Supposedly 2 divided by 10 is equals to 0 because there is no remainder. So simple to say, in linear search, every time you check one by one, so kapag may magkapareho or magka-match na item, ayun na po yung sagot doon. So for example, we need to search the key of 2. So simple to say that we found at the index of 2 because 0 is not equal to 2, 1 is not equal to 2, and finally 2 is equals to 2. So that's why I replaced that key 2 in the index of 2. Anyway, there is a collision there between 12 and 2, like what I have said earlier. Kapag maka-encounter po tayo ng collision sa separate chaining, ay gagawa lang po tayo ng box sa gilid kung saan magkakaroon ng collision. So that ang mangyayari po dyan ay magkatabi ang 12 at 2 sa may table index of 2. So next is 3 mod 10 is equals to 3. There have a collision between the 3 and 3. So we simply put the 13 and 3 sa gilid ng table index of 3. So next 23 mod 10 is equals to 3. Also simple to say there is a collision there. So we put that 23 sa gilid ng table index of 3 together with 13 and 3. 5 mod 10 is equals to 5. And lastly, 15 mod 10 is equals to 15. So there is a collision there. So ilalagay lang po natin yan sa gilid ng table index of 5 together with 5, key 5. So I have a question about what if we encounter that collision. So we simply to say that we need to calculate that one until we resolve that collision. So I'm going to demonstrate that one after this. So here we are in the next step in solving the hash, which is the linear proving. So as we can see that I have already answered the problem, but I'm going to explain that one. So basically from this step, resolve the collision by following the formula, which is in the top. So let's start the search. 12 mod 10 is equals to 2. 18 mod 10 is equals to 8. 13 mod 10 is equals to 3. 2 mod 10 is equals to 2. So there is a collision there between 12 and 2. So we need to calculate that one. So first, we need to apply the formula, which is the h of x is equals to h of x plus f of I mod 10. So where f of I is equals to 0, 1, 2, 3, and so on. So let's start to solve the key to h of 2 is equals to h of 2 plus f1. So why I started from f1? Suppose we need to start to in f of 0, because I know that h of 2 is equals to h of 2 plus f of 0 mod 10 is equals to 2. So that's why I started in f of 1. So anyway, h of 2 is equals to h of 2 plus f of 1 mod 10 is equals to 3, because 2 mod 10 is equals to 2. Therefore 2 plus 1 is equals to 3. Since table on index of 3 is present there, so we need to search it again until we got the answer. So h of 2 is equals to h of 2 plus, this time, f of 2 mod 10 is equals to 4. Since there is a blank index there, we simply to put that 2 in the table index of 4. So next, 3 mod 10 is equals to 3. Also, there is a collision again, so we need to calculate that one. So here, h of 3 is equals to h of 3 plus f1 mod 10 is equals to 4. Since table index of 4 is present there, so we need to search it again. So h of 3 is equals to h of 3 plus f2 mod 10 is equals to 5. We simply to say that we put that key 3 in the table index of 5, since table index of 5 is not present there. So next is the key 23. 23 mod 10 is equals to 3. Also there is a collision there, so we need to calculate that one. So h of 23 is equals to h of 23 plus f1 mod 10 is equals to 4. Since index of 4 is present, so we search it again. H of 23 is equals to h23 plus 2 f of 2 mod 10 is equals to 5. Since 5 is present, also we need to search it again. So h of 3 is equals to h of 23. H of 23 is equals to h of 23 plus f3 mod 10 is equals to 6. So finally, we found a table at the table index of 6. So we put that 23 at the table of index of 6. So next, 5 mod 10 is equals to 5. So there is a collision there. So we need to search that one also. So h of 5 is equals to h of 5 plus f of 1 mod 10 is equals to 6. So 6, since 6 is present there, then we need to search it again. So h of 5 is equals to h of 5 plus f of 2 mod 10 is equals to 7. So here we go. That key 5 at table index of 7. So next, the key 15. So 15 mod 10 is equals to 5. So there is a collision also. So we need to search it again. So h of 15 is equals to h of 15 plus f of 1 mod 10 is equals to 6. So since 6 is present there, so we need to search it again. So h of 15 is equals to h of 15 plus f2 mod 10 is equals to 7. So since the same answer there, so 7 is present, we search it again. So we need to search we need to search it again. So h of 15 is equals to h of 15 plus f of 3 mod 10 is equals to 8. So 8 is present there, so we need to search it again. So h of 15 is equals to h of 15 plus f of 4 mod 10 is equals to 9. So finally we found the key 15 at the table index of 9. Quadratic proving. So from this step, we need to resolve the collision also, just like what I did in the linear proving, but the formula is different, so later I will discuss that formula. So let's start to solve. So 12 mod 10 is equals to 2. Next is 18 mod 10 is equals to 8. Next is the 13 mod 10 is equals to 3. 2 mod 10 is equals to 2. So there is a collision. So first I will discuss the formula before we calculate that one. So the formula from quadratic proving is h of x is equals to h of x plus f of y squared. So mod 10. So why there have a square there? Because we need to multiply that one. So here let's start to solve the key 2. h of 2 is equals to h of 2 plus 1 times 1 mod 10 is equals to 3. So index 3 is present, so we need to search it again. H of 2 is equals to h of 2 plus 2 times 2 mod 10 is equals to 6. So we found the key 2 in the index of 6. So next, key 3 mod 10 is equals to 3. So there is a collision there, so we need to calculate that one also. So here h of 3 is equals to h of 3 plus 1 times 1 mod 10 is equals to 4. So we found the key 3 at the index of 4. So next, 23 mod 10 is equals to 3. So there is a collision there also. So we need to calculate that one. So here h of 23 is equals to h of 23 plus 1 times 1 mod 10 is equals to 4 is equals to 4. So since 4 is present there, so we need to search it again. So here h of 23 is equals to h of 23 plus 2 times 2 mod 10 is equals to 8. So index 8 is present there, so we need to search it again. So here h of 23 is equals to h of 23 plus 3 times 3 mod 10 is equals to 12. So since the answer is 12 and we have only the size of 10 in our hash table, so therefore we better to ignore that one. So next, 5 mod 10 is equals to 5. Next is 15 mod 10 is equals to 5. So there is a collision again. So we need to search that one. So here, h of 15 is equals to h of 15 plus 1 times 1 mod 10 is equals to 6. So since index of 6 is present there, so we need to search it again. So h of 15 is equals to h of 15 plus 2 times 2 mod 10 is equals to 12. So since it's the same scenario with the key 23, so better to ignore that one. So as we can see, I have already solved the problem, but don't worry about that because I will explain that one. So from this last step is all about double hashing. So probably from this step uses the idea of applying the second hash function to E when a collision occurs. So later I will explain the formula there. So let's start to solve. 12 mod 10 is equals to 2. Next is 18 mod 10 is equals to 8. Next is the 13 mod 10 is equals to 3. Next is 2 mod 10 is equals to 2. So there is a collision there. So let's start to solve that one. So first I will discuss the formula. So the formula from this step is basically we need to apply the first formula, just what I have used we have used in the separate chaining, which is the h1 of x is equals to x mod 10. Then the second formula, which is the h2 of x is equals to 7 minus open brackets x mod 10. So why there is a 7 in the formula, second formula? Because simple to say that for what is the nearest and less than of the size of 10 is equals to 7. So why is 7 and not is 8? Simple to say 7 is less than 8, therefore 7 is the nearest in the size of 10. So let's start to solve the key 2. So here h of 2 is equals to 2 plus 1 times 6. So where do I get that 6? Simple to say that in the second formula, which is we calculate 7 minus 2 open brackets 2 mod 7. So based on the order of the operators, so we need first to calculate inside the brackets. So 2 mod 7 is equals to 1. Therefore 7 minus 1 is equals to 6. So that is why I get that 6. So anyway, h of 2 is equals to 2 plus 1 times 6 mod 10 is equals to 13. So since the size of our hash table is 10 only, so we just ignore that one. Next, 3 mod 10 is equals to 3. So there is a collision there, so we search that one. h of 3 is equals to 3 plus 1 times 1 mod 10 is equals to 19. So since the size of our hash table is 10, so simple to say that we just to ignore that one also. So next is 23 mod 10. So there is a collision also, so we need to search it again, that one. So here h of 23 is equals to 3 plus 1 times 6 mod 10 is equals to 7. So since index 7 is blank, then we put that 23 in the index of 7. So next is 5 mod 10 is equals to 5. Next is the 15 mod 10 is equals to 5. So there is a collision again also, so we search that one. So here h of 15 is equals to 5 plus 1 times 5 mod 10 is equals to 1. So we found that key 15 at the index of 1. So basically, if we encounter the collision, so we need to search and search until we got the answer. So that's all. Thanks for watching.